Today, we're going to add ripples to the liquid in our fantasy style health meter. Let's go. In the last few episodes, we've been building this health meter. It's a bit complex, so I broke it apart into several episodes. Last week, we added the red liquid, and today we're going to add the ripples to the top of the liquid. The most valuable thing about this series of videos so far is not necessarily the UI elements that we've been building, like this health meter. It's the set of subgraph nodes that we've been building along the way. You can use these to build all kinds of different user interface elements and other 2D effects. These are building blocks or shortcuts that make it faster to achieve the results you want. If you haven't been following along with the series so far, I've put a link in the description for each of these nodes, so you can find the one you need and then quickly jump to the video where I show you how to make it. So if I add one of these nodes in the graph today, you'll know where to find it. All right, in order to add ripples to the top of our liquid today, we're going to make a new subgraph. And by the way, we'll start out in Unity today, and then in a few minutes, I'll show you how to do this in Unreal as well. So let's make a new subgraph. So we'll go Create, Shader Graph, Subgraph, and we're just going to call this subgraph Waves. And we'll open it up and jump right in. All right, so the first thing that we do when we create a new subgraph, and this is really common, we're going to create a vector2 parameter and call it UV. And then we'll come over here to our graph inspector and check the use custom binding box and set the label to UV0. And now we'll bring our UV coordinates in and create a branch on input connection node and hook up the UV coordinates to both the input and connected. And then we'll just create a set of default UV coordinates that we can connect up to this input port here. So when there's nothing connected to the UVs, they'll get the default UVs. All right, the next thing that we need to do is start making the wave. And waves have three properties. They have speed, they have distance between the waves, which is called frequency, and they have height, which is also called amplitude. So we're going to set up our waves with these controls. For frequency, we can just add a frequency parameter. And we'll make this frequency parameter a vector2 and call it frequency. And we're going to default the frequency to 2 and 2. And we'll go ahead and bring in our frequency here. And all we need to do to use the frequency is just multiply it by the UV coordinates that we've created so far. All right, and then we can take those values and split them out. So right now we have a U and a V coordinate multiplied by our frequency. And what we're going to do is just take that U and V and add them together like this. And now these values are ready to be used. But we need to work up here in the top half of our graph first. I talked about adding speed, so we need to bring time into our graph. And so we'll just add a linear time node. And this is one of those nodes that we've created previously that's linked down in the description. All right, so we want people to be able to either animate these or not animate these. So what I'm going to do is add a new parameter here that's a float, and I'm going to call it movement. So if I wanted movement to be time, I could pass time into this parameter. But if I wanted to be still, I could just add a static value. So I'm going to bring in movement here, and we'll add a branch on input connection node, and I'm going to plug movement. Oh, I need to check the use custom binding box here. And we'll set our label to linear time because that's what it's going to be by default. So I'll connect up my movement here. And then for linear time, I'm going to connect loop to the not connected input port there. There we go. So when you don't connect anything to this movement input port, it's just going to use linear time set to a speed of 0.3 by default. Okay, and I also want to give users the control over the phase. And so I'm going to add a new parameter here called phase. And we're going to default phase to 0. And then I'm going to add phase to time just to give users just a little bit more control over the waves. All right, so we've got our movement set up here. We brought in our time. And we've got our frequency here that's being controlled by the UV coordinates. And now we just need to take the two of these and add them together. So we'll add time and we'll add in our UV coordinates or our frequency. And now the next thing that we need to do is we're going to multiply our result by tau. So I'm going to add a multiply node there, and I'm going to add tau. Tau is a constant, and it's basically 2 times pi. And the reason that we're doing this is because we're going to use a sine wave node. The heart of our effect is sine. And let me just explain this a little bit. So what we've created up until this point is a value that just continuously increments. It just continuously rises and goes up and up and up. And we're going to plug it into sine. And sine is going to take this this linear value that continually goes up, and it's going to turn it into a wave. So I'm going to plug this in here, and you'll see now, instead of values that are just solid white because they're continually going higher and higher, this value is much higher than 1, by the way. Instead of that, what we're getting now is these waves. And the reason that they're traveling diagonally is because we added our x and our y together here. And then the reason that we added tau here is because sine takes a value that's in radians. So multiplying our value by tau is basically like converting it into radians so that we can then get predictable values used by the sine wave. Okay, so we've got the very basics of our wave here. The next thing that we need to do is add a parameter that lets us control the strength or the height of these waves. And we're going to call this parameter amplitude. So I'm going to create a vector 2 and call it amplitude. And we'll bring in our amplitude and we'll multiply it by the result of our sine wave. So the default value that we give to amplitude, obviously it's set to 0 right now. But for defaults for the amplitude, I'm going to set this to 0.07 and 0.05. Now you can see we've just kind of weakened our waves there, kind of toned them down a little bit. And the reason that we did that is because we're going to add them to our UV coordinates, and we don't want the alteration of the UVs to be too strong. So now that I've multiplied our sine wave by our amplitude, we can bring in an add node here, and we're going to add these values to our original UV coordinates. So here are our UVs coming in, and I'm just going to grab this value and bring it over here and add them to the value that we've computed for our waves here so far. And if you look really carefully, you can see these UV coordinates waving. We have to keep it subtle because if you alter UV coordinates with too much strength, the resulting image or pattern that you create is just crazy looking. And so we've kind of toned that down with the amplitude value so that it's not too strong. Okay, and so this is the result that we were looking for. And the next thing that we need to do is just pass this out. So I'm going to come over here to our output, and we're going to call the value out and set it to be a vector 2. And we'll just connect that up right there. We also want to pass out this pattern that we've created here. And so I'm going to add a new output here, and we're just going to call this one raw. And I'm going to pass out our raw value as well. We need to make sure we set this to be a vector 2 so that you can either use the UVs coming out of here, or if you just want to use the wave pattern as it is without it being added to the UVs, you can use the raw value there. So that kind of makes this node like dual purpose. You can create waves in a UV pattern or in UV coordinates, or you can just use the waves as they are. Okay, this node is basically done now. There are just a couple of things that we need to do to finish it off. We need to set the preview to 2D. We need to set the path to procedural UV. And there's a specific order that I want these parameters to be in. I'm going to set it to UVs, then amplitude, then frequency, and then phase, and then movement. All right, so our wave node is all set. So here you can take a good look at the whole thing. And I'll go ahead and save this, and we'll add it to our fantasy meter that we've been building. All right, so here's the graph for our fantasy meter. And in order to create these waves, here is the linear gradient that we're using to generate the liquid here. And if we open it up, you can see we've got a UV input here. And this is where we need to add our wave subgraph. So we'll open it up. We'll go to procedural UV, and there's the wave subgraph that we just barely created. So we can bring this thing in, and we'll connect up the UV coordinates that the wave subgraph is generating and plug those into our linear gradient. And let's take a look at the results that we're getting now. Look at that. Now we've got some waves on our liquid. But these waves look maybe a little bit too strong. So let's tone this down a little bit just to get some results that are a little bit more natural. We're going to set our amplitude to 0.02, 0.02. And now we're getting something that looks a little bit better. But I also want to control the speed of these things. So for the movement input, I'm going to add a linear time node. So you can see here that by default, our movement is already linear time, but I don't have any way of controlling the speed value of that linear time. And so I'm going to, whoops, I added linear gradient. I wanted a linear time node. There we go. So you can see that this default speed of linear time is 0.3, but I actually want to set this to a value of 0.7 just so that we can speed up our waves a little bit. So I'm going to take the loop value out of here and pass it into the movement value there. And now that's going to allow us to create these ripples that are just a little bit faster. All right, let's go ahead and clean things up here. Just kind of minimize our waves node, minimize our linear time node, minimize our linear gradient node, and we're all set. So now if we come up here, actually let me just connect this slider here in place of our health parameter, just temporarily so that we can visualize this. If we come up here to the end of our graph, now I can control this slider to raise and lower the liquid that's inside our health meter. And you can see when it's all the way at the top, the waves are kind of off the top of the crystal sphere. When I bring it down, now you can see these waves giving this indication that what we've got inside our crystal sphere is liquid and not just like a solid, I don't know, gelatin or something. So yeah, so that's how we've created the waves for our health meter. And this just adds like a little bit of interest. It's not necessarily required. And so I guess if you wanted to make a cheaper version of this thing, you could leave the waves off and just let the liquid be static and flat. But it looks a lot more interesting this way, I think. All right, next week we're going to add bubbles to our liquid. So it feels like the liquid is infused with magical power or something. We're going to have bubbles that are kind of traveling up here. So make sure you come back next week for that. And in the meantime, let's go ahead and jump over to Unreal, and I'll show you how to create the waves in the liquid in that game engine as well. All right, here we are in Unreal Engine, and here's the graph that we've created so far that creates the fantasy meter here in Unreal, just like we've been building it in Unity. All right, so we need to create waves on the top of our liquid. And in order to do that, we're going to create a new material function that creates waves in UV coordinates. And then we're going to plug them in right here to our UV channel input of our linear gradient node so that we can make the the top of our liquid ripple. So let's come down here to our content drawer, come into our shaders folder in procedural and UVs. And I'm going to hit the right click here and we'll pick material function, and we'll call this material function waves, and we'll double click it, open it up and get started. All right, the first thing that we're going to do is create a function input, and this one we're going to call UV, and we'll set it to be a vector 2. And then for the default, we're going to create just the default texture coordinates and plug those into the preview so that if somebody doesn't connect something to this input here, it'll default to using just the texture coordinates. All right, so what we need to do to our texture coordinates is multiply them by a frequency input. So I'm going to add a multiply node here, and we're going to add a new input, and we're going to set this to be a vector 2, and this is going to be called frequency. And we're basically scaling the texture coordinates by the frequency, and that will control like the distance between the waves. So for our frequency, we're going to set the default value here to 2 and 2. And we need to make sure that we check this use preview value as default box down here. All right, so this is controlling the frequency of the waves, or how often, or the distance between the wave peaks. And now we need to create the time, or bring in some time. And so we're going to bring in the linear time node that we created previously. But we don't always necessarily want our waves to be animated. We want the user to be able to control if they're animated or not. So I'm going to bring in a new function input again. And this one we're going to call movement. And movement is just going to be a scalar. So I'm going to default that to, we'll default it to 0. But actually I want to check this use preview as default value. And if nothing is plugged into movement, then we're going to use looping linear time for our movement. So that way, if you want to move this thing yourself, you can plug in your own value here. Or if you just leave nothing plugged in, it's going to go ahead and use time. And we also want to give the user a little bit of control over this. So I'm going to add another input. We're just full of inputs today. And we're going to call this one phase. And this is going to allow the user to offset the phase of that movement if they want to. So we just need to add phase to the input time. And so this allows them to move the waves back and forth inside the time that they're animating. All right, so now I can just take my time element and my UV coordinate element and add them together like this. Oh, there's one thing that I forgot here. Let's do this really quickly. We need to split apart the UV coordinates that we've created here. And so the way that I'm going to do this is with a component mask. I'm just going to grab the red. And then for this one, I'm just going to grab the green. So we're splitting apart the red and the green here. And now I'm just going to add them together. And so I get a value that is the sum of the U coordinate and the V coordinate. And so now that I've done that, we're ready to take these coordinates here and add them together with our time component. Okay, and now we're going to add the heart of the effect, which is a sine wave. So I'm going to plug my value into the sine wave. And now if we take a look here at our preview, you can see that we've got these nice sine waves going on. I'm going to go ahead and preview this node over here so you can see these waves that we've created. And we have a bunch of parameters that we've added. So we can offset the phase. We can control the speed of the movement. We can control the frequency of the waves, and we can also pass in different texture coordinates if we want our waves to look a little bit different. Okay, and I am noticing one thing that I want to change here. In Unity, the V coordinate is flipped, and so it goes in a different direction. And so in Unreal here, I'm getting these waves that are going up, and I actually want the waves to go down. And so in order to fix that, all I need to do is bring in a multiply node here. And I'm going to multiply by a value of 1 and -1. And this is basically just flipping that that V coordinate so that I can get the waves to move down and to the left instead of up and to the left. All right, so now I've got waves that are the same in both Unreal and Unity. And so the pattern will match. All right, so I've got my sine wave output here. But these waves are just a little bit too strong. And so what I need to do is give the user the ability to control the height of the waves or the amplitude. So we're going to add a multiply here. And I'm going to add another input. And we're going to set this one to be a scalar. And I'm going to set it to be called amplitude. And I'm going to default my amplitude to 0.07 and 0.05. And we'll come down here and check this use preview value as default. And then we'll multiply the output of our sine wave by our amplitude. And now you can see that has reduced the strength of our waves. All right, so now that we've done that, we can just add our original UV coordinates that we brought in here to the result of these waves that we've created. So I'll make an add node. And then we'll add our original UV coordinates. And we can plug that into our output result. And we'll go ahead and preview that result. And yeah, now it looks like this, and you can see that we've got our nice waves that are distorting our UV coordinates in a wave pattern. Now, I also want to allow the user to not add the waves to the UVs, but just take the raw result. And so we're going to create another function output, and we're going to call this one raw. This one we're just going to call out. And with this one, instead of adding the UV coordinates here, I'm just going to take the raw results and pass that out. So now you can see if the user wanted this nice wave pattern, they could get that instead. Looks like I made a mistake here. I set our amplitude to be a scalar, and I actually want this to be a vector 2. So I'm going to fix that really quick. And I think that we're all set. There are just a couple of last things that we need to set here. We're going to put this into a category. Instead of miscellaneous, I want to put it into the procedural UV category. And I think that should do it for us. So let's go ahead and save our graph. And we'll jump back to our fantasy meter and start using that material function to create our waves. So now I just need to come down here to our procedural category and to our UVs. And it looks like I need to check this exposed to library box, which I forgot about. And also, I guess I could add a description here if I wanted to. I'll let you guys do that, but I'm just going to move on here. We'll come down here to our procedurals category, our procedural category, UV, and there it is. There's our waves material function. And so here, coming out of out, we can plug this into our UV channel. And now it's giving us an error. So let's take a look at what we did wrong. So we have this phase input that we forgot to check that all important box. This is just a little bit annoying. So we'll come back here to our waves material function and find our phase. And we got to check this box here. Use preview value as default. That way our phase, which is defaulting to 0, won't cause an error. All right, the other thing that I want to do is make sure that we have these input values in the right order. So our UVs that are coming in, that's going to be priority 0. Then we're going to have our amplitude next, so we'll set that to 1. Then we're going to have our frequency next, so that we'll set that to 2. After frequency is phase, so we'll set that to 3. And then finally, movement is going to be set to 4. All right, so we'll save that. Come back here. Now we've got everything in the right order, and our error is gone, thank goodness. And we've got these cool looking waves on the surface of our liquid. But the waves are a little bit too strong. We need to tone it down with our amplitude value here. And so for amplitude, I'm going to give it a value of 0.02. 0.02, and plug that into amplitude. And then we want to control the speed just a little bit as well. I think these waves are just a little bit too slow. And so we're going to bring in the linear time node. And for this, and we'll plug that into our movement input here. And for our speed, we're going to set our speed to 0.07 and plug that into speed. Oh, actually, it's a little bit too slow. So I'm going to set it to 0.7. And there we go. Now we've got some nice waves. And they're about the right height. And we've got everything set up just the way we want it to be. All right, I'm really happy with the way that this is turning out. We can control this health value here. The higher I set this value, the higher the meter is going to be. So now we got our waves way up there. Or we can bring these down to 0.2, have little ripples down here, or put it back right there into the center at 0.5. So this is pretty cool. We've got our waves going on. We've got our liquid with its nice translucency. We've got our crystal sphere with its reflections and its specular highlight. Next week, we're going to add bubbles to our liquid. That's going to be a good one. So make sure to come back for that. And in the meantime, have a great week, everybody.